Hi everyone, today we're going to be doing algebra proofs. And the reason we're going to do algebra proofs is you're probably thinking, I already took algebra, I don't need to do that. Well, that's exactly why we're going to do algebra proofs, is because you already know algebra, and that way you can practice doing two-column proofs and know all the, get all the understanding from that. So we're going to go ahead and start with thinking about the properties of equality. Now, the properties of equality, what do we know about equations? Both sides have to be equal. That's why you have this equality word here. So we're going to start with the addition property. And we start that by saying if A is equal to B, then A plus C is equal to B plus C. In other words, if we add something to one side, we have to do it to the other side. Subtraction property. If A is equal to B, then A minus C is equal to B minus C. And remember, the way this is set up, we talked about this with our conditional statements. You start with the if, and that's your hypothesis. And then you've got your then, and that's your conclusion. Okay, so let's talk about multiplication property. If A is equal to B, then we would say A times C is equal to B times C, because we're going to multiply both sides by the same thing. And if this is all looking familiar, this is exactly how we isolate a variable and how we solve an algebraic equation. But this time, with each step, we have to explain it all. So for division property, if A is equal to B, then A divided by C is equal to B divided by C. Then looking at distributive property, if A times B plus C, if we have an A times B plus C, then A times B plus C is equal to, if we did distribution, A times B plus A times C. So those are ones that you're probably familiar with. Then there's a few more that maybe you're not as familiar with. So let's take a look at those. So the next one is substitution property. And we say that if A is equal to B, if A is equal to B, then A may be replaced if A is equal to B, then A may be replaced. A may be replaced by B in any expression or equation. And with the reflexive property, what that means is for any real number A is equal to A, meaning that a value always equals itself. Symmetric property, that's where if you have if A is equal to B, then B is equal to A. You're just going to switch sides of the equal sign. And finally, the transitive property, think of the word transfer. Think of the word transfer. If A is equal to B and B is equal to C, we're just going to transfer this and say, because they're both equal to B, we're going to say that A is equal to C. So then we can say that A is equal to C. Again, we're just transferring the A to the C because both of them equal B. All right, let's start a proof, right? Our first proof here. When we do these, we have to list out our properties. We're just going to list out the properties for each one. So if K is equal to 1, then 3 is equal to K. That is our symmetric property. And then on this next one, if 2x is equal to 14, then x is equal to 7, you ask yourself, what did they do to both sides to get x equal to 7? Well, they divided. So this is the division property. Okay, they've divided both sides by 2. On number 3, remember the one where a value will always equal itself? That is 10y is equal to 10y. That's your reflexive property. Now this next one, what did they do here? They added 1 to each side, so that's going to be addition property. I'm just going to abbreviate that word now. And on number 5, if 10a is equal to 2b and 2b is equal to c, hopefully this is coming back to you, then what we have there is 10a is equal to c. We transferred the 10a to the c, cutting out those two b's. So that is your transitive property. All right. I want you to pause the video and try the next 5 on your own and then check back. Okay. So hopefully on number 6, hopefully you got distributive property. And then on number 7, hopefully you got subtraction. Number 8 was substitution, because you are substituting that w is equal to 1. You're substituting to the w. So that's your substitution. Number 9 is transitive, because you're transferring the 3x to the z. And number 10 is addition property. So let's pause the video and let's try the next group. Okay, on this next group, hopefully you got on number 10 addition property, and then symmetric property for 11, substitution property for 12, for 13 multiplication property, and for 14 hopefully you got distributive property. So it's important to get very fluid and fast in understanding those, because we're going to need them for our proofs on the next page. Okay, so we're going to be working on these proofs today and probably through Monday. So let's get busy. What is a two-column proof? A two-column proof is a common format used to organize a proof where we have the statements or the steps are listed on one side. The statements are listed on one side, and the reason is going to be on the right side. Oops, what did I spell there? The reason. Okay. Now, what can be used as reasons? Well, what we just learned, or what we just went through, was all our properties of equalities. So we certainly could use our properties. We can also use definitions and postulates and theorems. Okay, so let's look at this first one and do the steps to prove it. Okay, on number 1, given 4x minus 1 is equal to 27, prove that x is equal to 7. So in other words, we would look at this and we'd say solve for x. Well, they're telling us what x is, and we have to go through the steps and prove it. So one thing that's important to know when you do proofs is you're going to start with the statement that they give you, and then you're going to rewrite it and mark it as given. So they gave us this, and we're going to rewrite it here, and then the first line is always going to be given. Now the next line, how did we go from 1 to 2? We added 1. So that is going to be your addition property. And then on the last one, how did they get x equal to 7? Well, they clearly divided. So that is your division property. On number 2, what are we doing to get from, we're going to rewrite it. We're going to rewrite our statement. And then after we rewrite it, we always say given. Now, how did we go from a divided by negative x plus 2 is equal to 5 to a divided by a negative 6 is equal to 3? Well, clearly, we subtracted 2 from either side. So that is going to be our subtraction property. So whatever step you did, there is a property for it that you're going to write that down. And finally, how do we get from a is equal to a negative 18? How do you undo division? You're going to multiply both sides by negative 6. So that's how we got that. So we are going to call that multiplication property. Okay? Now, this next one, we're going to start out with, you should recognize that as, well, first we're going to do that, we're going to rewrite it, and we're always going to say that it's given. And then you should recognize that how they got from step 1 to step 2 is the distributive property. And then how did they get from step 2 to step 3? That was the subtraction. They subtracted 27. And finally, how did they get negative 2? Well, they divided both sides by negative 18. So that's how we get our division property. Okay, so a few more here. So given 6x plus 7 is equal to 8x minus 17, prove that x is equal to 12. So how we're going to rewrite the statement that's given. Now, how did they go from number 2 to number 3? I'm sorry, from number 1 to number 2 on this one is that they used subtraction. They subtracted from either side. And then after that, they simplified. So let's talk about that. They just simplified by, actually what the simplification happens in the next one. What they did is they added 17 to either side. And then after that, you guessed it, division property. And finally, all they did here is they wanted to get the variable on the left side. So if you notice, you've got 12 is equal to x, and they just switched it to get the x on that side. And in doing so, remember the property where it equals, if a is equal to b, then b is equal to a. That is your good old symmetric property. And you will do this when you want to have that variable on the left and you're just going to switch sides with that. Okay. Okay. At this point, I'm going to let you do number 6 and 7 on your own. Okay. So complete that with your notes. Okay. Let's do a few more. Like I said, it's been a while since we've done algebra, so we need to clear out the algebra cobwebs. And what we're doing on number 8, the first thing we're going to do on number 8 is after we look at our first statements here. Hopefully when you did numbers 6 and 7 on your own, you realized that they did not have the first statement. So we need to do that with this. And we're just going to rewrite 5y minus 1 over 2. That's going to, and also put the number 1. That's our first step. Put number 1 there. Is equal to 7. And the first thing we're doing, that is given. Remember, that's always going to be your first one, is you're going to call that's given. And then on number 2, we are multiplying both sides by 2. So we're going to call this, if we do that, we end up with 5y minus 1 is equal to 14. And we call that our multiplication property. Okay? After we do that, we are going to add 1 to either side. So that's going to give us 5y is equal to 15. That's our addition property. And finally, to get the y by itself, on step 4, we're going to end up with y is equal to 3. And how did that happen? Well, that's our division property. Okay? All right. I want you to go ahead and do numbers 9 and 10 on your own. But remember, the first step that we have to do is we're going to rewrite this as 10k minus 4 is equal to 2k minus 20. And we write that, remember, we're going to write that as given. And then solve from there. So go ahead and do numbers 9 and 10 on your own. Okay. The last one that we're going to do today is number 11. And we're going to start out by rewriting it. So we're going to have 14 minus 2 times x plus 8 is equal to 5x minus 3x minus 34. And that is our given. Now, the next step we can see is we're going to distribute, because in our next step, we will have 14 minus 2x minus 16, because we're going to multiply negative 2 times x and negative 2 times 8, is equal to 5x. Now remember, whenever you have that negative in front of something without a coefficient there, you assume that's a negative 1. So you assume that you are going to multiply a negative 1 times what's inside of the parentheses. So we're going to have 5x minus 3x plus the 34. And that, of course, we just performed the distributive property. On our next step, this is where we're going to combine like terms. So we've got a 14 here and a negative 16 here. And over here we have a 5x and a 3x. Those are like terms. So if we rewrite this, we're going to have 14 minus 16 and then this negative 2x. So we're going to do negative 2x minus 2 is equal to, we're going to combine the 5x minus 3x to give us 2x plus 34. And that's what we're just going to call our step 3, which is just to simplify. On step 4, what's happening on step 4 is we are going to do subtraction property, okay? Because we are going to subtract 2x from either side. So we'll have a negative 4x minus 2 is equal to 34. We just subtracted this 2x from either side. That's how we got the negative 4x. Minus 2 is equal to 34. And that's our subtraction property. Then on number 5, We've got a negative 4x is equal to 36. And how did that happen? Well, we added 2 to each side. So that's our addition property. And finally, on number 6, how did we get finally that x is equal to negative 9? Well, we divided. So that's our division property. So hopefully you took good notes, and then you did the ones that I didn't do. Take a picture and upload to Canvas, and we will continue to practice tomorrow.